For millions of years they were the undisputed masters of the earth. Titans of flesh and bone, they roamed a vibrant, sun-drenched world. But their reign was ended not by a rival, but by a silent traveller from the stars. It arrived without warning, a mountain of rock and ice moving faster than any sound. The moment of impact was the beginning of the end, unleashing forces beyond comprehension. The skies burned, the oceans raged, and the planet was shaken to its very core. Yet, the true challenge was still to come. As a shroud of dust and ash enveloped the globe, the sun vanished. A long, unnatural twilight descended, heralding an age of bitter cold and profound silence. This is the story of that winter, a decade of darkness that followed the giants, and the tale of the unlikely survivors who inherited a new world. The world, 66 million years ago, was a masterpiece of life, a planet teeming with giants under a warm, stable sun. This was the late Cretaceous Period, the zenith of a biological dynasty that had ruled for over 150 million years. In the heart of what would one day be North America, vast inland seas shimmered, their shores fringed with subtropical forests of towering conifers, ferns, and the first flowering plants. The air was thick, rich with oxygen, and filled with the calls of exotic birds and the buzz of insects. This was a world in its prime, a complex and balanced ecosystem unaware of its own fragility. Here, the dinosaurs were the undisputed masters. Herds of Triceratops, with their formidable horns and bony frills, moved through the undergrowth like living fortresses, their young sheltered in the center of the herd. Graceful, long-necked Alamosaurus browsed the high canopy, their immense size a testament to the planet's abundance. In the skies, pterosaurs like the colossal Quetzalcoatlus, with wingspans rivaling a small aircraft, soared on thermal updrafts, casting fleeting shadows on the land below. And in the shadows, there was the apex predator, Tyrannosaurus rex. Not a lumbering monster, but a sophisticated hunter, its keen senses of sight and smell constantly sampling the air for opportunity. It moved with a predatory grace, a perfectly engineered creature at the top of a food chain that had been stable for eons. Life was a continuous cycle of pursuit and evasion, of birth and the end of life, governed by instinct and the rhythm of the seasons. The smaller creatures, mammals the size of shrews, scurried in the leaf litter, living their lives in the margins, their time yet to come. On this day, the sun rose as it always had. The air was warm, the forests were vibrant, and the great reptiles went about their daily existence. There was no omen, no sign of the profound change that was imminent. The world was loud, green, and full of life. But for those with eyes to see, a new point of light had appeared in the daytime sky. It was small, insignificant, easily lost in the glare of the sun. It did not twinkle like a star, nor did it wander like a planet. It simply grew, minute by minute, a silent harbinger on a collision course with destiny. Far beyond the vibrant world of the dinosaurs it travelled, a solitary wanderer adrift in the cold, silent expanse of the solar system. It was an asteroid, a relic from the dawn of creation, born from the same primordial cloud of dust and gas that formed the sun and its planets over 4.5 billion years ago. For eons, it had orbited peacefully in the belt between Mars and Jupiter, one of millions of similar bodies, a silent witness to the formation of worlds. But millions of years before its fateful appointment with Earth, a gravitational nudge, a cosmic billiard shot from a passing giant like Jupiter, had altered its path. It was cast out of its stable orbit and sent on a long, looping journey toward the inner solar system. This was no mere rock. It was a composite of stone and dense metals like iron and nickel, a solid, irregular mass forged in the crucible of the early solar system. It carried with it the memory of cosmic antiquity, its surface pitted and scarred from countless smaller impacts over billions of years. As it hurtled through the vacuum of space, it was cold, inert, and utterly silent, tumbling slowly on its axis. Its speed was almost incomprehensible, many times faster than a rifle bullet. It was not burning, for there was no air in space to ignite. It was a dark, almost invisible projectile, reflecting only the faint, distant light of the sun. Its new trajectory was an intersecting line, an inescapable path that would bring it across the orbit of Mars, then Earth, then Venus, before swinging back out into the void. But this time, the geometry was different. This time, a blue and white marble would be in the way. As it closed the final 100 million miles, Earth would have grown in its view from a bright star to a discernible disk. It crossed the orbit of the Moon, a mere cosmic stone's throw away from its target. The planet's immense gravity took hold, pulling the traveller in, accelerating it in the final stage of its long fall. To the creatures below, it was now a brilliant light in the sky, brighter than any star. A new sun had appeared, growing in intensity with each passing second, a silent, beautiful, and terrifying spectacle against the familiar blue canvas. The messenger from the void was about to deliver its message. Comprehending the scale of the approaching object is a challenge for the human mind. It was approximately 6 miles or 10 kilometers in diameter. If it were to touch down on a modern city, its edges would loom over the entire metropolitan area. If stood on its end, it would reach far higher than Mount Everest, well into the stratosphere where commercial jets fly. This was not a rock falling from the sky, it was a mountain. As this celestial mountain plunged towards the Gulf of Mexico, its immense velocity became the critical factor. Traveling at over 40,000 miles per hour, it compressed the atmosphere in front of it into a superheated plasma. The air itself, unable to move out of the way fast enough, was heated to a temperature several times hotter than the surface of the sun. This created a blinding fireball, a leading shield of incandescent light that would have been the brightest thing any creature had ever seen. For the dinosaurs in the vicinity, the final moments would have been surreal. The sky would have split open with a light of impossible intensity, casting sharp, stark shadows across the land. The heat from this atmospheric compression would have been felt hundreds of miles away, a sudden, searing wave of warmth. The object itself was now visible, no longer a point of light, but a discernible shape within the fireball, growing larger at an alarming rate. It descended at a steep angle, a cataclysmic arrow aimed at the heart of the planet's richest ecosystems. The target was a shallow, tropical sea off the coast of the Yucatan Peninsula. The water offered no protection. To an object of this size and speed, a few hundred feet of ocean was no more of an obstacle than a thin sheet of paper. The journey of millions of years was over in a flash. The final 1,000th of a second before impact, the world was silent. The light was absolute. The ancient rock, forged in the birth of the solar system, made contact. At that instant, the kinetic energy of the asteroid, the energy of its motion, was converted into an explosive force that beggars description. The front of the asteroid vaporized the sea and the limestone bedrock beneath it, while the back of the asteroid was still miles up in the atmosphere. The world had just been struck by a cosmic hammer. The moment of impact was not an explosion in the conventional sense, it was a planetary resurfacing event. The initial transfer of energy was so immense that it is difficult to quantify. In the first second, a crater over 60 miles wide and 20 miles deep was blasted into the Earth's crust. The asteroid and a vast volume of the planet's surface were instantly vaporized, creating an expanding bubble of superheated rock gas. This blast generated a shock wave that traveled outwards at supersonic speeds, a moving wall of pressure that flattened everything in its path. For a radius of 1,000 miles, forests were obliterated, turned to splinters in an instant. But the more insidious effect came from above. The impact ejected trillions of tons of molten rock and debris high above the atmosphere, sending it on ballistic trajectories that would see it rain back down across the entire globe. As these tiny beads of glass and rock, known as spherules, re-entered the atmosphere, friction heated them to incandescence. The sky all over the world began to glow. Within an hour of the impact, the heavens filled with what looked like a global meteor shower of unprecedented intensity. The sky turned a dull, ominous red. This wasn't just a light show, it was a planetary-scale heat lamp. The combined thermal radiation from these re-entering particles was intense enough to heat the surface of the planet to oven-like temperatures. Dry leaves, pine needles, and grasslands spontaneously ignited. From North America to India, from the poles to the equator, the world began to burn. Global wildfires erupted on a scale never seen before or since. Entire continents were set ablaze, the fires consuming the lush Cretaceous forests and pumping enormous quantities of soot and ash into the upper atmosphere. Any animal not sheltered underground or in deep water was exposed to this lethal thermal pulse. The world that had been a vibrant green and blue was being systematically transformed into a planet of black and red. The hour of fire was just the beginning of a long, dark night. It was the first and perhaps most devastating step in creating a new, hostile environment, clearing the slate for the long winter that was to follow. While fire raged across the surface, the planet itself was reeling from the physical blow. The impact delivered a seismic shock of unimaginable power, estimated to be a magnitude 11 on the Richter scale, an earthquake more powerful than any modern human has ever recorded, by orders of magnitude. This titanic tremor radiated outwards from the point of impact, traveling through the Earth's crust at thousands of miles per hour. The ground across the North American continent would have buckled and heaved violently, triggering landslides that reshaped entire mountain ranges. But the shockwave did not stop at the coast. It travelled through the planet's mantle, a pulse of pure energy that reverberated around the globe. When this seismic energy converged on the opposite side of the planet in the region of modern-day India, it caused immense geological stress. This is believed to have triggered or massively amplified the activity of the Deccan Traps, a vast volcanic province that erupted on a colossal scale, pouring floods of lava across the land and releasing huge quantities of volcanic gases into the atmosphere. The planet was now being assaulted from two fronts, the impact in the west and massive volcanism in the east. Back at the impact site, the displacement of trillions of tons of rock and water created another terrifying consequence, a mega tsunami. The initial wave generated by the collapse of the transient crater may have been miles high, a wall of water that dwarfed any tsunami in recorded history. It radiated outwards across the Gulf of Mexico, scouring the coastlines of North and South America. The wave was so powerful it travelled deep into the interior of the continents, flooding landscapes that had not seen the sea for millions of years. Evidence of this great wave can be found today, hundreds of miles inland in Texas and other coastal states. As this wave propagated across the globe, it would have diminished in height but still arrived on distant shores as a series of catastrophic tsunamis, rearranging coastlines worldwide. The planet was in a state of complete chaos. It was shaken to its very core by the most powerful earthquake in its history. Its oceans were in turmoil, with colossal waves redrawing the maps. Its surface was ablaze with global fires, and its atmosphere was beginning to fill with the products of this cataclysm: soot, ash, and vaporized rock. The sun, the source of all life and energy, was slowly being obscured. The fires were burning out, the ground had stopped shaking, but a new and more persistent threat was descending, a profound, planet-altering chill. In the minutes following the impact, the Earth itself seemed to recoil. The asteroid, having displaced a shallow sea, punched a hole not just in the crust, but in the ocean itself. Water rushed into the superheated cavity, only to be violently expelled by the immense energy release. This was the birth of a wave unlike any in planetary history. A mega tsunami, initially estimated to be over a mile high, radiated outwards from the point of impact at the speed of a modern jetliner. It was not merely water, it was a churning slurry of rock, sediment and superheated steam, a liquid mountain scouring the floor of the Gulf of Mexico clean. As this initial wave train moved outwards, its power was almost incomprehensible. It struck the coastlines of what is now North and Central America, not as a wave, but as a temporary elevation of the entire sea level. Entire coastal plains were submerged in an instant, the water pushing hundreds of miles inland, stripping away soil, forests, and every living thing. The geological evidence for this event is staggering. In sites as far away as Texas and the Dakotas, scientists have uncovered a thick, chaotic layer of sediment, filled with a jumble of marine and terrestrial fossils, a permanent scar left by the water's violent intrusion. This was not a flood. It was a planetary-scale resurfacing event. But the devastation was not limited to the Gulf. The impact generated a seismic shock that rippled through the planet's crust, triggering earthquakes of magnitude 11 or greater everywhere on Earth. These quakes in turn set off sympathetic tsunamis in every major ocean basin. The Pacific, the Atlantic, the Tethys Sea, all were agitated into a frenzy. Coastlines across the globe, from South America to Africa, were battered by waves hundreds of feet high. These were not the orderly waves of a storm. They were chaotic, unpredictable surges that rearranged geography in a matter of hours. Low-lying islands were erased from existence. Coastal ecosystems that had been stable for millions of years vanished beneath the torrent. For any creature that had survived the initial heat blast, the world's oceans had now become an unstoppable force of annihilation. The water was not a source of life, but the agent of a global cataclysm, a great drowning that left nowhere to hide. And as the waters finally began to recede, they revealed a shattered world, unaware that the true ordeal, the long period of cold and shadow, was only just beginning. After the fury of the waves subsided, a new and more insidious change began. The sky, once a familiar blue, was transforming. The impact had vaporized not only the 6-mile-wide asteroid, but also a vast portion of the Yucatan's limestone and gypsum bedrock. Trillions of tons of pulverized rock, soot from continent-spanning wildfires, and sulfur aerosols were propelled high into the stratosphere, far above the weather. This colossal plume of debris did not fall back to Earth. Instead, it began to spread, carried by high-altitude winds, an ever-expanding shroud for the planet. Within hours, then days, this veil of ejecta encircled the globe. For any observer on the ground, the effect would have been profoundly disorienting. The sun, the constant source of energy and light, began to dim. First, it would have appeared as if behind a thick haze, its light turning a strange, reddish hue. Then, as the stratospheric blanket thickened, it faded further, becoming a faint, ghostly disk in a perpetually twilit sky. Finally, it disappeared entirely. The world was plunged into a profound, unnatural twilight, a state of near total lightlessness that would persist not for a day or a week, but for years. The familiar cycle of day and night was obliterated, replaced by an unceasing, oppressive gloom. The moon and stars vanished, hidden behind the same impenetrable curtain. This was not a simple cloud cover. The particles suspended in the stratosphere were exceptionally effective at scattering and blocking sunlight. Scientific models based on the composition of the impact layer found in the geological record suggest that the amount of light reaching the Earth's surface may have dropped by over 99%. The planet was effectively flying blind through space. This sudden removal of solar energy was the trigger for the next global catastrophe. The great heat engine that drives our planet's climate and sustains its ecosystems had been switched off. The initial shock of the impact was a violent, fiery event, but this new phase was quiet, cold, and absolute. The sun, the very heart of the world's life systems, had been eclipsed. On a planet now shrouded and still, the survivors of the initial cataclysm faced a new and terrifying reality. A world without a sun. A world where the sky itself had turned against them. The world without a sun did not cool gracefully. It endured one final paradoxical burst of extreme heat. As the heavier particles of ejected rock and molten glass rained back down through the atmosphere, friction heated them to incandescence. For several hours the sky glowed. The atmosphere itself became a radiant oven, raising surface temperatures high enough to ignite the world's forests. Continent-sized wildfires raged, consuming vast tracts of vegetation and sending yet more soot and ash into the stratosphere, thickening the sun-blocking shroud. This planetary-scale firestorm was followed by an equally extreme chemical assault. The vaporized gypsum from the impact site had released enormous quantities of sulfur into the air. This sulfur combined with water vapor to form sulfuric acid, which then fell back to Earth as a persistent, corrosive acid rain. The rain fell for months, perhaps even years, altering the chemistry of the soil and, most critically, the surface waters of the oceans. Marine ecosystems, particularly those reliant on organisms with calcium carbonate shells like plankton and ammonites, faced a chemical crisis. The very water they lived in became hostile to their existence. This acidification of the ocean surface was a silent but devastating blow to the foundation of the marine food web. After the fire and the acid came the cold. With the sun's energy blocked, global temperatures began to plummet at an alarming rate. The long twilight was not just a visual phenomenon, it was a thermal one. The planet was now radiating more heat into space than it was receiving, initiating a runaway cooling effect. This was the beginning of the true impact winter. The survivors, having endured the initial blast, the tsunamis, the radiant heat, and the acid rain, now faced a world that was growing colder by the day. The rules of survival had changed completely. It was no longer about being the strongest or the fastest. It was about enduring a hostile alien environment where the fundamental constants of light and warmth had been stripped away. In the dim, perpetual twilight, new forms of life, like fungi that thrive on decay, began to dominate the landscape. The age of reptiles was ending and a new, fungal world was emerging from the ruins. The cooling that began in the long twilight soon escalated into a planetary deep freeze. With the sun's warmth almost entirely cut off, the Earth's climate system was thrown into chaos. Global average temperatures fell drastically by as much as 25 degrees Celsius or 45 degrees Fahrenheit. This climatic shift was both rapid and relentless. Tropical and subtropical regions, which had known stable, warm climates for millions of years, experienced freezing temperatures for the first time. The world of the dinosaurs, a hothouse planet of lush jungles and warm seas, was transforming into an icebox. The consequences were profound. Freshwater lakes and rivers began to freeze over, first at the poles and temperate latitudes, and then spreading towards the equator. This locked away a vital resource for terrestrial animals and fundamentally altered aquatic ecosystems. On land, the ground froze solid, making it impossible for burrowing animals to find shelter or for plants to draw nutrients. The seasons, once a predictable cycle of wet and dry or warm and cool, ceased to exist, replaced by a monotonous, unrelenting cold. Snow began to fall in places it had never fallen before, blanketing the dying forests in a layer of white. This global refrigeration created a powerful filter for survival. Cold-blooded animals, including the remaining non-avian dinosaurs, were at a severe disadvantage. Their metabolisms were dependent on external heat. In a world without sun and with plummeting ambient temperatures, they would have grown sluggish, unable to hunt, forage, or escape the cold. Their large bodies, once an advantage, now became a liability, requiring enormous amounts of energy they could no longer obtain. In contrast, small, warm-blooded creatures had a potential edge. Mammals and birds, with their insulating fur and feathers and their ability to generate their own body heat, were better equipped for the new climate. They could remain active in the cold, seeking out the last vestiges of food and shelter in the frozen landscape. The impact, winter was not just a weather event, it was an evolutionary crucible, a brutal test that favored the small, the adaptable, and the warm-blooded. The planet was being remade, forged in ice, and only those organisms that could withstand the planetary freezer had any chance of seeing the sun again. The ultimate foundation of nearly all life on Earth is photosynthesis, the simple, elegant process by which plants and microbes convert sunlight into chemical energy. The impact, winter, brought this fundamental engine of life to a screeching halt. In the perpetual twilight that shrouded the planet, there was simply not enough light for photosynthesis to occur. On land, the great forests of conifers, ferns, and flowering plants began to wither. Unable to produce food, they shed their leaves and slowly starved. The planet's green mantle faded to brown and grey. The silence in these dying forests would have been absolute. In the oceans, the catastrophe was even more swift and complete. The surface waters were home to countless species of phytoplankton, microscopic algae that form the base of the entire marine food web. Like plants on land, they required sunlight to live. As the sun vanished, this floating pasture of the sea collapsed. Trillions of organisms perished, their remains sinking to the ocean floor. This event is clearly marked in the fossil record by the plankton gap, a layer of rock where these once abundant microfossils suddenly disappear. Their demise sent a shockwave up the food chain. The tiny zooplankton that fed on them vanished next. Then came the small fish and invertebrates, followed by larger predators like the great marine reptiles. The entire complex structure of ocean life, built over eons, disintegrated from the bottom up in a matter of months. This was the Great Famine. On land, the herbivores, from the giant Tyrannosaurs to the armored ankylosaurs, found their food sources gone. They were the first of the dinosaurs to face oblivion. The carnivores, like Tyrannosaurus rex, would have survived a short time longer, scavenging on the abundant remains. But soon, that final food source would be exhausted. The entire energy system of the Cretaceous world had been unplugged. Survival now depended on finding alternative food sources, things that did not rely on fresh sunlight. The only viable strategy was to feed on the great planetary compost pile, the immense amount of decaying organic matter left over from the old world. This shifted the advantage to scavengers, decomposers, and detritivores, creatures that could live on the dead. For the titans that had ruled the earth, the game was over. The photosynthesis famine was the final, inescapable consequence of a sky without a sun. The end did not come with a roar, but with a flash of impossible light. For the colossal creatures that had dominated the planet for 150 million years, the final day was like any other. A Tyrannosaurus patrolled its territory, its senses honed for the hunt. Herds of Triceratops moved through fern prairies, their great frills a display of ancient majesty. In an instant, their world was torn apart. The initial impact sent a shockwave expanding at supersonic speeds, leveling forests for thousands of kilometers. But the true end was delivered by the sky itself. The ejector thrown into orbit rained back down as superheated glass beads, turning the atmosphere into a planetary-scale convection oven. The air temperature spiked to hundreds of degrees, igniting global wildfires that consumed entire continents in a matter of hours. There was no escape. For the titans of the Mesozoic, their size, once their greatest advantage, became their fatal flaw. They were too large to shelter, too exposed to the searing heat. The intricate ecosystems they anchored simply ceased to exist. The great plant-eaters found their food sources incinerated, and the carnivores who hunted them were left with a barren, burning world. In the span of a single day, the geological blink of an eye, the age of reptiles was brought to a calamitous close. The sounds that had defined the Cretaceous period, the heavy footfalls, the territorial calls, the symphony of a vibrant world, faded into an eerie silence. The giants had fallen not to a rival predator or a changing climate, but to a visitor from the cosmos. Their reign was over. The throne of the world was now vacant, and the planet was a scorched, empty stage, waiting for new actors to emerge from the ashes. But first, the world would have to endure a long, punishing night, an unnatural winter that would test the very limits of life itself. In the perpetual twilight that followed the impact, a new power rose to inherit the earth. It was not an animal, nor was it a plant. It was the vast, interconnected kingdom of fungi. With the sun blotted out by a thick veil of soot and dust, photosynthesis on a global scale ground to a halt. The world's forests were reduced to charcoal and endless fields of decaying organic matter. For the fungi, this was not an apocalypse. It was a feast. The fossil record from this period reveals what scientists call a fungal spike, a thin layer in the rock teeming with fungal spores, a silent testament to their temporary global dominance. Imagine a world without green, a landscape draped in shades of grey, white, and brown. Vast, ghostly webs of mycelium, the root-like structures of fungi threaded through the ash-covered soil, diligently breaking down the remains of the Cretaceous world. Strange mushrooms, some perhaps bioluminescent, would have sprouted from the rotting logs of giant trees, providing faint, alien light in the gloom. This was the planet's great decomposition event. The fungi were the planet's recyclers, the cleanup crew, working on a planetary scale. They were unlocking the nutrients trapped in the immense biomass of the fallen world, slowly preparing the soil for an eventual rebirth. For years, they were the undisputed rulers. They thrived in the low-light, high-moisture conditions of the impact winter. While the surface world was hostile to almost everything else, it was a paradise for them. This fungal world was a bridge between two epochs, a strange, quiet, and essential chapter where the old world was consumed to make way for the new. Beneath this blanket of decay, the planet was not truly inert. The groundwork was being laid for the next stage of recovery, a slow process that would depend on the very nutrients the fungi were now releasing back into the wounded earth. While the giants perished on the surface, a different story unfolded in the shadows. Life, tenacious and adaptable, found refuge in the small spaces of a broken world. The survivors of the great cataclysm were not the strong, but the small, the versatile, and the hidden. Tiny, shrew-like mammals, no larger than mice, had a crucial advantage. They could burrow. As the sky burned, they sought shelter underground, insulated from the worst of the heat. In the cold, dark years that followed, their small size was again a blessing. They needed less food, and their varied diet allowed them to subsist on what little the ravaged world could offer: insects, worms, roots, and seeds that survived the fires. Among these early pioneers were creatures like Purgatorius, a proto-primate that scurried through the undergrowth of a world it would one day inherit. For these creatures, life was a constant, desperate search. The world was a monochrome landscape of ash and ruin, punctuated by the skeletal remains of the former rulers. The air was cold, the sunlight a distant memory. Every foray from the burrow was a risk, a gamble for a mouthful of food in a world of scarcity. They were the bottom of a shattered food chain, but they were alive. Other survivors shared this strategy of staying small and out of sight. Certain species of birds whose ancestors had evolved from small, feathered dinosaurs endured. Their ability to fly offered some advantage, but it was their ground-dwelling, seed-eating cousins that fared best. In freshwater rivers and lakes, crocodiles and turtles, shielded by the water, managed to persist. Their slow metabolisms allowed them to endure long periods with little food. These were the humble architects of the future. They were not impressive, not mighty, but they possessed the single most important trait for the times: resilience. They were the living seeds from which the entire Cenozoic era, the age of mammals, would eventually bloom. The devastation was not confined to the land. The world's oceans, once teeming with colossal marine reptiles and vibrant reefs, suffered a collapse of staggering proportions. The impact triggered mega-tsunamis that scoured coastlines, but the more profound damage came from the sky. The lack of sunlight caused a catastrophic die-off of phytoplankton, the microscopic algae that formed the base of the entire marine food web. Without this primary producer, the chain of life unraveled. The great ammonites, with their iconic spiral shells, vanished completely. The fearsome mosasaurs and long-necked plesiosaurs, the apex predators of the seas, were starved into oblivion. The surface waters became a vast, sterile expanse. But far below, in the crushing pressure and absolute dark of the abyssal plains, some communities were insulated from the surface chaos. Life here did not depend on the sun. Around hydrothermal vents, volcanic fissures in the ocean floor, entire ecosystems thrived on chemosynthesis. Bacteria drew energy not from light, but from the chemical-rich water spewing from the Earth's interior. These oases of life became crucial sanctuaries. Tube worms, strange crabs, and hardy fish, all adapted to this extreme environment, continued their existence oblivious to the drama unfolding thousands of meters above. They represented a flicker of continuity in the marine realm. These deep-sea refugees were not enough to prevent a mass extinction event in the oceans, but they ensured that life itself would not be extinguished. They were the reservoirs from which the seas would slowly, over millions of years, be repopulated. The recovery of the oceans would be a long and arduous process, beginning in these isolated pockets of warmth and chemical energy. The deep, once considered a barren wasteland, had become a cradle, safeguarding the genetic legacy of the marine world until the sun finally returned to the surface. The first 10 years after the impact were a time of profound stillness. The planet, once loud with the movements of giants, fell into a deep and pervasive quiet. The impact, winter held the world in its grip, a long, cold twilight, where temperatures remained stubbornly low. The dust and aerosols in the stratosphere still scattered the meagre sunlight, casting the world in a perpetual gloom. This was the decade of stillness, an eerie interlude between destruction and recovery. The dominant sound was the whisper of the wind across barren plains of ash. The dominant sight was a world of grey, broken only by the skeletal architecture of the dead. But slowly, imperceptibly, the planet began to heal. The first signs of a true recovery were not grand, but humble. After the fungal kingdom had done its work, the fern spike began. Hardy, opportunistic ferns whose spores could travel vast distances and germinate in disturbed soil started to colonize the ash. Patches of resilient green began to appear, the first color in a monochrome world. This was a critical turning point. As these ferns spread, they began the slow process of stabilizing the soil and restarting the engine of photosynthesis on a meaningful scale. As the ferns took hold, the atmosphere itself began a gradual process of clearing. With less dust to block the sun, more light reached the surface. The deep cold began to recede, inch by inch. For the mammalian survivors, this was a signal. With the first reliable food sources in years, they could emerge from their burrows with more confidence. Their world was still empty and dangerous, but it was no longer completely barren. The decade of stillness was an age of ghosts, haunted by the memory of a lost world. But it was also the dawn of a new one. As the first true sunrise in years finally broke through the thinning haze, it illuminated a planet scrubbed clean, a blank slate ready for the next great chapter of life to be written. For years, perhaps more than a decade, the world had been trapped in a perpetual twilight. The sun was not a memory, but a myth whispered in the instincts of the survivors. A thick, persistent shroud of stratospheric soot and sulfuric acid aerosols ejected by the impact formed a global barrier against the light. Temperatures had plunged, creating a planet of ice and gloom. The oceans, once teeming with vibrant life, became acidic and cold, their surfaces choked with debris. On land, the acid rain fell relentlessly, stripping nutrients from the dead soil and poisoning the water. Life, where it persisted, did so in the margins, in burrows, in deep-sea vents, in the quiet patience of seeds and spores. It was a world held in suspended animation, waiting for a dawn that seemed would never come. But high above the frozen surface, a slow, imperceptible change was beginning. The laws of physics are patient and absolute. The heaviest particles of rock and dust had fallen back to Earth in the months following the impact, but the finest aerosols were light enough to remain suspended for years. Gradually, these microscopic particles of sulfuric acid began to clump together, growing heavier until gravity could finally pull them from the sky. The soot, product of continent-spanning wildfires, also began to aggregate and descend. The atmospheric shield, once impenetrable, was starting to thin. It was not a sudden event, no dramatic parting of the heavens. Instead, it was a subtle shift over many seasons, a gradual dilution of the gloom. For the creatures that had endured the long night, the first hint of change would have been nearly undetectable, a slight lessening of the oppressive twilight, a faint shift in the quality of the ambient gloom. Then, one day, a true beam of sunlight might have pierced the haze for the first time in a generation. It would not have been the warm, golden light of the Cretaceous, but a weak, watery illumination filtered through the remaining atmospheric grime. For organisms adapted to near total darkness, this initial light could have been as shocking as the darkness that preceded it. Eyes that had evolved for sensitivity would now be overwhelmed. Creatures that relied on stealth would find their cover diminished. The returning light, however faint, was a catalyst for immense physical change. As the sun's energy began to touch the planet's surface once more, the great sheets of ice and frost that had accumulated over the years started to melt. This was not a gentle spring thaw. It was a global deluge. Water, locked away as ice, was released in colossal volumes, carving new rivers through the ash-covered continents and triggering landslides on an unimaginable scale. The world was being scoured clean. The returning light did not reveal a world ready for recovery. It revealed a landscape of raw, unstable devastation. The long winter was ending, but the planet was now entering a new age of chaos, an age of water and mud. The promise of a new dawn was inseparable from the threat of the Great Flood. The returning sun illuminated a world scrubbed clean of its former glory. The vibrant, complex ecosystems of the late Cretaceous, the towering forests, the flowering meadows, the lush wetlands, were gone. In their place was a monochrome canvas of grey ash, brown mud, and sterile rock. The intricate web of life had been torn apart, leaving a biological vacuum. In this empty world, the first organisms to reclaim the land would not be the mighty, but the opportunistic. They were the planet's emergency first responders, and they came in the form of trillions of microscopic spores riding the winds over the desolate continents. Geologists see this moment preserved in stone. In the rock layers directly overlaying the boundary of the extinction event, there is a sudden, dramatic shift. The rich diversity of pollen from countless species of Cretaceous plants vanishes, replaced by a single, overwhelming signal: fern spores. This layer, sometimes composed of over 99% fern spores, is known as the fern spike. It is the fossilized record of a planetary-scale ecological takeover. For a period lasting thousands of years, Earth was not a world of forests or grasslands, it was a world of ferns. This monotonous green carpet was a sign of life's resilience, but also a stark indicator of the ecosystem's profound impoverishment. Why ferns? They are the ultimate disaster specialists. Their method of reproduction, using lightweight spores instead of seeds, is key to their success. A single fern can release millions of spores, which can travel for thousands of miles on atmospheric currents, allowing them to colonize distant, isolated patches of habitable ground. These spores can lie dormant for extended periods, waiting for the precise moment when light and moisture return. Furthermore, many fern species are adapted to thrive in disturbed, nutrient-poor environments, exactly the conditions found across the post-impact world. They require no pollinators and can spread rapidly via underground stems called rhizomes, quickly covering the sterile ground with a tenacious grip. Imagine this world. From horizon to horizon, a seemingly endless, uniform sea of green. The same few hardy species of fern dominating every landscape from the newly carved riverbanks to the eroded hillsides. For the few animal survivors, this was a mixed blessing. The greening of the planet meant the return of a primary food source and the stabilization of the soil. But ferns are not particularly nutritious. They offer far less energy than the flowering plants and seeds that had sustained many Cretaceous herbivores. This new world was a low-energy world, capable of supporting only the most adaptable and least demanding of appetites. The fern spike was a planetary scab, a protective layer over a grievous wound. It was the first essential step toward healing, but the world it created was a pale, quiet shadow of the one that had been lost. Beneath the fronds, the next stage of evolution was quietly waiting for its chance. The reign of the ferns, though absolute, was temporary. It was a crucial phase of planetary stabilization, a living bandage that held the soil together and began the slow process of converting sunlight back into life. But as the ferns enriched the sterile ground with organic matter, they inadvertently prepared the way for their own successors. The first flowering plants, or angiosperms, began to challenge the fern monopoly. These were not the spectacular specialized flowers of the late Cretaceous. They were hardy pioneers, fast-growing, wind-pollinated species, likely relatives of modern sycamores, birches, and poplars. Their seeds, more robust than spores, found purchase in the improving soil, and their saplings reached for the sky, casting the first new shadows upon the land. Slowly, over millennia, the monotonous green carpet gave way to the first forests of the Paleocene. These were not the complex, multi-layered jungles the dinosaurs had known. They were simpler, less diverse ecosystems, dominated by a handful of successful species. The world was green again, but it was also profoundly quiet. The Cretaceous soundscape had been a cacophony of life. The bellows and footfalls of giant sauropods, the calls of pterosaurs, the chirps and clicks of a billion specialized insects. Now, silence dominated. The loudest sounds were inorganic, the rush of the wind through the new leaves, the gurgle of water in the recovering streams. The air lacked the vibrant hum of a healthy ecosystem. The great beasts were gone, and their absence left an acoustic void that would take millions of years to fill. This quietness was a reflection of the world's missing pieces. The megafauna, the giant herbivores that had acted as the engineers of the Cretaceous landscape, were extinct. Without them, the new forests grew in ways they never could have before. There were no colossal browsers to thin the canopy or clear paths through the undergrowth. As a result, the early Paleocene forests were likely denser and more tangled, a uniform wilderness of new growth. This new vegetation structure, in turn, created different kinds of opportunities for the animal survivors. Life was re-establishing its rhythm, but it was a simpler, slower beat. The intricate dance between predator and prey, plant and pollinator, was being choreographed anew with a much smaller cast of characters. Meanwhile, the planet itself was continuing to heal. The resurgence of plant life on a global scale had a profound effect on the atmosphere. Through photosynthesis, these new forests began to draw down the immense quantities of carbon dioxide that had been released into the air by the impact and the global fires. This process was a crucial thermostat, helping to stabilize the climate after the wild swings of the impact winter and the subsequent warming period. A new equilibrium was being established. The world was a vast, green and quiet place, a blank slate. The great ecological roles once filled by the dinosaurs stood vacant. It was an empty stage, waiting for a new cast of evolutionary actors to emerge from the wings. For 150 million years they had lived in the shadows of giants. Our ancestors, the mammals of the Mesozoic era, were largely small, nocturnal creatures. Resembling shrews or opossums, they scurried through the undergrowth, hunting insects by night and hiding from dinosaurs by day. Their survival depended on being inconspicuous, adaptable, and quick. They were constrained by a world ruled by reptiles, their evolutionary potential held in check. The impact that annihilated the dinosaurs did not just remove a threat, it shattered the cage. For the first time, the world belonged to the mammals. The principle is known as ecological release. When a dominant group of species is removed from an ecosystem, the organisms they once suppressed are suddenly free to expand and diversify into the newly vacant niches. This is precisely what happened to mammals in the aftermath of the extinction. With their main predators and competitors gone, they stepped out of the darkness and into the daylight. The result was one of the most explosive evolutionary radiations in the planet's history. Within the first million years of the Paleocene, a geological instant, mammals began to experiment with new forms and sizes on a breathtaking scale. This initial wave of mammalian pioneers produced some strange and unfamiliar beasts. There were the pantodonts, some of the first mammals to achieve large size, evolving from small insect eaters into cow-sized herbivores in just a few million years. There were the taniodonts, powerfully built animals with rodent-like incisors and strong claws, adapted for digging up roots and tubers, and there were the multituberculates, a highly successful group of rodent-like mammals that had existed alongside the dinosaurs but flourished after their demise, only to be outcompeted later by true rodents. These were the first drafts of a new mammalian world, evolutionary experiments filling the void. What gave mammals their decisive edge? Their fundamental biology was perfectly suited for the post-apocalyptic world. Being warm-blooded or endothermic allowed them to regulate their own body temperature, a critical advantage in the unstable and still relatively cool global climate. Their complex, differentiated teeth enabled them to process a wide variety of foods, from tough plants to other animals. And their comparatively larger brains provided the cognitive flexibility needed to adapt to the rapidly changing environment. Furthermore, providing milk for their young gave mammalian offspring a vital head start, a nutritious and reliable food source in a world of scarcity. The age of reptiles had ended in fire and ice. Now, in the quiet green forests of the New World, a different kind of animal was on the move. They were no longer just survivors hiding in the margins, they were explorers, pioneers, and the new inheritors of the Earth. The age of mammals had truly begun. Our existence is a product of cosmic chance. Had the asteroid been a few minutes earlier or later in its journey, it would have missed our planet. Had it struck a deep ocean instead of the shallow sea off the Yucatan Peninsula, the climatic consequences might have been survivable for the dinosaurs. In any of those alternate timelines, the world would likely still belong to the great reptiles, and our ancestors would remain small, furtive creatures of the night. The story of humanity, therefore, does not begin with the first hominids in Africa, but in the crucible of the impact 66 million years ago. The devastation of that event is inextricably woven into our own evolutionary identity. We carry the legacy of our deep past within our very biology. The nocturnal bottleneck hypothesis suggests that many defining mammalian traits are relics of the 150 million years spent hiding from dinosaurs. Our acute hearing, our sensitive sense of touch via whiskers and fingertips, and our powerful sense of smell were all honed in the darkness. The extinction event allowed our ancestors to bring these nocturnal adaptations into the daylight, repurposing them for a new world. We are creatures of the night who inherited the day. More specifically, the extinction directly paved the way for the evolution of primates. The global recovery was led by flowering plants which created vast new forests filled with fruits, nuts, and insects. This arboreal banquet presented a unique opportunity. An animal that could navigate this complex, three-dimensional world would thrive. This selective pressure favored the evolution of grasping hands and feet to move securely among branches. It favored forward-facing eyes, providing the stereoscopic vision necessary for judging distances. And it favored larger, more complex brains to process this flood of visual information and to remember the locations of seasonal food sources. We are, in a very real sense, the children of those first new forests. Look at your own hands, your ability to perceive a rich spectrum of color, your reliance on sight over smell. These are not just human traits. They are primate traits forged in the world that rose from the ashes of the dinosaurs. The dexterity that allows us to build cities and create art began as an adaptation for clinging to a branch. The color vision that allows us to appreciate a sunset evolved to spot a ripe piece of fruit against a background of green leaves. The cataclysm cleared the stage, and the ecological opportunities that followed guided our lineage toward intelligence and curiosity. The story of the impact winter is more than a history of ancient catastrophe. It is our origin story. It is a profound lesson in the fragility of dominance and the power of adaptability. Every human being is a descendant of a creature that survived the single worst day in the history of life, that endured a decade of darkness, and that seized the opportunity of a renewed world. That unbroken chain of survival, stretching back across 66 million years of upheaval and change, is the ultimate legacy written in our DNA.